Now this video talks about serial transmission and parallel transmission, and then we'll talk a little bit about signal impairment as well, or things that stop the transmission being as good as it could be. So first of all, serial transmission, each binary bit, they're sent one after another. So we end up with something that looks like this, approximately, where we have a set of binary bits and one cable. We've got something like this where we've got one binary bit that's going from one position down to the end. So this 0 is going to be on the cable and then arrive at this end. So each bit is sent in turn. So one advantage of serial transmission is that all the bits always arrive in the correct order. So usually a serial cable will have two cables, one for one direction, one for the other. They don't have to, they could have just one, but usually they have one cable for each direction. It makes it quicker. So we could say that they send a voltage obviously down the cable, which represents our binary 1 or binary 0. So that can be just an on or off, or a high or lower voltage. So as we said, there's usually a dedicated wire for each direction. So serial transmission is the type of transmission we normally use these days. It's good for long distances because we don't need a timing signal for it. And because we don't need a timing signal, then it doesn't suffer from what we call data skew, like parallel transmission, which we'll look at in a moment. So serial is good for long distance. Because we need fewer cables, we could sometimes say that it's cheaper as well than parallel. But remember, in the exam, if you're going to say cheaper, you've got to say why. So at least minimum, say less cables needed. There's actually a bit less hardware needed as well at either end. So you've got to minimum say that. So never just say cheaper in the exam without saying something about why, because you're just not going to get the points. So that's serial transmission. So serial transmission, and these cables are serial cables. They look like this, so you might come across those in your computer system if you have a look inside. So parallel transmission. So this relies on having lots of different wires that all run at the same time. So this is an old-fashioned parallel port. If you've got an old computer, you might look on the back of it and find a parallel port like this. So each one of these holes here would take a wire, and these wires would send data at the same time. So there are several wires that all transmit the data a bit at a time on each wire. So that means we've got this idea of having each binary bit will have its own wire, and they'll all go at the same time. And that's why it's called parallel, because they're all these wires in parallel. So if you had 8 wires, you could send 8 times as much data as you could at one time with a serial cable, because with serial we can only send one bit on one cable at a time. So because all the data has to arrive at the same time, we have to have a timing signal. So as well as the actual wires, there's a timing signal, a clock on this as well, which uses a strobe for timing. And if data is delayed, it leads to data skew. So if one piece of data here arrives first, and then these other pieces of data are not quite there yet, we're going to get this idea of data skew, and it won't be able to be read correctly because we won't be able to sort out which order they're in. So data skew is a problem with parallel. So building equipment to send and receive data this way is more expensive. It's more expensive because there are more wires and there is more complex hardware. We need the timing signal, we need a separate cable for the timing signal, and it's more complex to set up the system. It used to be used a lot more because it was a lot faster, because we literally sent lots of data at the same time instead of one after another. It's not used so much anymore because USB serial interfaces have become really quick, much faster. We can send data a lot faster than we used to be able to. However, you might still come across a hard disk interface, used to be called ATA, or a printer cable Centronics. This is a Centronics port here for a parallel printer. You might still come across them in old computers or in an old, maybe an old picture of a computer. It's not really used so much anymore for that, but we do still use parallel in the internal buses. So as we've said, they need a clock signal to keep them in time. So they're synchronous systems. So they must be synchronized with the timing signal. And over a long distance, that can be more difficult to keep all the data in time. So they're not so suitable for long distance. So, shorter distance. Shorter distances are more suitable for this. Shorter distance. I wrote that out because it was rubbish writing. So that's parallel. So what can cause issues in parallel communication can actually be caused in any kind of communication, some of these, but it certainly is a problem in parallel. So signal impairment. So if you send a signal from your transmitter, it becomes weaker the further from the transmitter it goes. That's called attenuation. So the signal attenuates. So if your signal starts off like this, it's probably going to attenuate off as it goes further along. So it takes longer than that, but that's the idea. So it'll attenuate, it will get weaker as we go further along. So we can regenerate that signal. So we can send it into a regeneration station and regenerate it and then send it again. That works much better with serial than it does with parallel, to be able to do that. So there are some other factors that can impair the signal strength, such as interference. So it could be interference from other signals. If you've got multiple cables next to each other, they suffer from crosstalk. And crosstalk is where the cables interfere with each other as the signal goes along. So the signals going along the cable, they radiate some of their signal and crosstalk can happen. So you can also get other things. There's channel noise that can be created by heat, mains voltage signals. If you've got a mains cable close to your cable, you can get interference from that. And if you set up a PA system ever, you'll know that that's not a good thing to have your mains cable right next to your program cables, because you often get this mains voltage sort of 50 hertz noise. You can get distortion caused by all sorts of other things. So weather, other cables, proximity, microwave ovens, perhaps, anything that could potentially interfere with the signal. So twisted pair cables, you've probably heard of this idea as UTP, universal twisted pair cables. They're twisted to help prevent crosstalk, because the twisting pattern gives a cancelling effect on the interference caused. So there's all sorts of things that can impair our signal, and a lot of the time they are related to the problems with parallel transmission. So the main things to remember on this is that parallel transmission needs a timing signal. It can suffer from data skew, and it's not very good for long distances, whereas serial doesn't suffer from data skew, sends one bit at a time, and it's much better for long distances.